Hey, how's it going, everybody? Slip, and just a short video today. Not so long ago, let me just open up a terminal here. Not so long ago, I think I showed you this little syntax that I came up with, and this is basically just a sort of like a regex syntax. Useful for like parsing files and things like that. Talking, about programs, right? So parsing source code is sort of the point of this. Now, this is all well and good, but I just this is it's kind of silly, right? But I just realized that there is something very much like this in Perl already. What do you know? Uh, it appears that even though I have slightly criticized some of the Perl developers recently, that in some areas we are of a singular mind. That's what it would seem. Now, what I'm talking about, all right, it's right here. Okay, so I just realized that we have this name capture, and just you look, this is almost like the PLPS syntax. It kind of you know goes to show I might not be so crazy after all. But anyhow, now the difference is whereas in PLPS you say, for instance, type, and that would correspond to an already defined list of types. What you're doing here is you named your capture group, and then you define a pattern, and then whatever whatever matches that will be put into this how is it, something like this. Yeah, it will be put into this sort of capture group, which is actually kind of yeah, it's pretty cool, but anyhow, and in learning all of this new regex syntax, I realized that Perl is actually meant to crunch files, right? And what I mean by this, it's supposed to read a file and read it quick and be really good at text manipulation. So at first, I was a little bit hesitant. To try and pass regexes through a whole file, right? Because I have some source files that are thousands upon thousands of lines long, so it didn't seem to me like it would be a good idea. But just as a little benchmark here, I have this project I'm in. It's actually it's a lot of lines of code, but check this out. If I use this little program I wrote, which it's doing some heavy use of regular expressions in order to find certain patterns within a multitude of files. And what I'm doing here is I'm taking one file at a time, reading it the whole way through, so reading the whole file at once, utilizing the orc function, so that's open, read, and close, right? So orc, and then doing some heavy regexing of that file, and then spitting out the occurrence of the pattern that we're looking for, and the line number where that pattern occurs. And just to show that that's actually kind of quick, let's just do a little test here. So R for recursive, S for the symbol I want to find, and I just want to find occurrences of use the lang module, and we're just going to go through the entire folder structure and see what happens. What? Okay, give me a sec here. So I was in use and I deleted it. Oh yeah, right. Okay, so I deleted a variable that was declared right here, thinking I wasn't using it, and yes, I was using it. So yeah, okay, let's do that. And you see, it went to the entire, it went through the entire project, just like that. This is at least, I don't know, this is 20, upwards of 20,000 lines of code. It's amazing. It just, it's almost instantaneous. So yeah, actually pretty fucking powerful. So if perl can do that so easily, then just passing a single file and doing heavy use of regex, no problem. And case in point, it really isn't. So I can just utilize this little regex I've written in here to find every subroutine within a file. And what I'm doing in here is I'm just fetching it and doing some cutting, right? I call it yeah, I call it cutting. But the idea is that you have, for instance, you say while and some statement statement, and then in here you have something else. Well, what you really want to know, reading the file for the first time, is that here there is a loop. That loop takes a condition, and here is the body of what the execution of that loop is. You don't want to dive into the body of a loop just yet, right? So you want to abstract that away. So what we do is we replace whatever is between the parentheses, between the parents, we replace it with a cut, right? So we cut and we give this a unique ID, right? So let's say this one is cut 0. And then we take everything that is within the body of the loop and we cut that as well, and we give it another unique ID. And there you go. The now this expression expands into this, and whenever you're ready, or if you even want to expand that expression to do further analysis, you can do it then. But no sooner, right? So when you're ready to expand, you can expand. So that's the idea here. And first we're doing this for strings, right? Because if we want to remove unnecessary white space, but we have this string in there somewhere, we don't want to remove the white spaces within the string, right? Because we used to have that, and now we have this, and that is not what we want. So yeah, we're doing a little bit of that with strings and regex and chars. Sorry, chars. And by char I mean it's sort of like the C programmer in me, I guess. Lamenting that this isn't just for a single character. But anyhow, just yeah, I call it char just because it's what makes sense to me. But actually, it would be strings without interpolation. That's what it would actually would be. But anyhow, and then we have a list of the limiters, and this is just being automatically generated. So what we do is we say, okay, we have this opening pattern, and this is the closing pattern for this the limiter. Just make me a regex to match that, and that's basically what. So if we go to Delm, sorry, here is the generator in action, and this one is actually quite simple, but just because with a single character pattern is trivial, it's actually quite kind of trivial to make. Here is for multi-character sequences, so that's a little bit more complex, but not quite. All right, so it's not that bad. Okay, but anyhow, we're utilizing these generated patterns, and we just iterate through them in order, right? Because we don't want to hide an entire scope and then being unable to detect certain patterns within it. So we want to do things sort of in order, right? So we, because the first one that is there is the first thing that will be hidden away, and thus, right? So just a little thing we have to do. But anyhow, what I'm doing then is I'm saving the cut strings, right? So for every token, right? So for every cut token that we have, we have a hash in which this key is equal to this. It's assigned the string in question. So the sequence that was abstracted away into a single token is contained within this hash, right? And so we kind of need we kind of need that data in order to expand the tokens. And so what we are doing is the cut function will create that hash and append to it, and then the dump strings will just give us the generated hash and just clean it up. And so we don't we don't wind up with with processing a whole file and having the IDs in the millions, right? So we don't want to do that. We want to have a list of tokens for the scope that we're working with, and then we want to free that memory as soon as possible, because right, if we're going to be working with files even larger than the ones I have, yeah, we kind of want to be as economic with it as we can, right? So ideally, we would be doing all of the processing that we need to do for this particular block as soon as possible, so that we can free the memory as soon as possible. For now, because it's a single file, it doesn't matter. But anyhow, with all of this data, then we can, for instance, grab one of the blocks that we read and then just print out the data, right? So the body of that block of code. And that's basically what we're going to do now. So let's see. And here we go. So this is the PCC function, which is just a play on GCC, right? So I just had to do it. Let me just show you the original. So soft PCC. What are you talking about? Soft PCC, and as you can see, this is just sort of like a handle. It's just like an entry point into calling a source filter. Basically, it calls Perl, and it gives it a source filter that just grabs your code and plays around with it. It's not really a compiler, but in the Perl world, sometimes people call a source filter a compiler. What you're gonna do? Anyhow, well, as you can see, this is a larger function, but here we have it abstracted away to just its base statements, right? And so, if we just want to get a general idea of what this function is doing, looking at this is good enough. If we have good enough comments. In here I made the error of not commenting, so that's bad on my part. But anyhow, right? So we can get a good idea of what is what, because here's the thing. Now we know that for every semicolon, we can just split the string at that point, and everything we have is a perfectly contained statement, and then we can expand that. So yeah, basically what we would do is we could very easily take this same approach, make it recursive, and then just basically parse Perl, but not really. I'm not gonna do that. I am a little bit crazy, but not that crazy, right? So we know that only Perl can parse Perl. However, when it comes to how do you say, to processing source code in order to basically change how the language works, or I guess introducing new constructs into the language, and then basically working this around like a preprocessor in which we just detect certain patterns in the code and expand them or contract them to a different kind of pattern, sort of like with a macro, like with a macro in C, where you just put all of the tedious boilerplate. You put it in a macro, and then you just, it's one expression, and that's that, right? Happy times. Well, I wouldn't handle it like macros specifically, but it's a pretty good example. We can do a lot of pretty cool stuff with this. Kind of like I showed you with the subroutine inlining. Well, we can do that, but on steroids, basically. So yeah, uh, good stuff ahead, man. Good stuff ahead. And yeah, that's it for me. Um, I guess in the next few weeks, I will be focusing on this. And I guess it will be an entire. I'm guessing it will be a little bit of an overhaul of the RD parser, but RD parser and PLPS as a whole. Um, but it's not bad because it will actually be better, and even though we're gonna have to deprecate a lot of code, you know that's still fine because we wind up with a better system that's actually faster. Because here's the thing: the way that the RD parser works. So this is the PLPS parser. Now the problem with this is it is doing this thing, right? So abstracting elements away, but not quite as thoroughly as this approach, right? So it's not quite as good. It's not quite as good, right? So it pains me to say it because I wrote the damn thing and I'm proud of it, but yeah, it's not quite as good. And so yeah, I found a better way to do it, and the hyper optimizer in me wants to do it because here's the here's the deal with this thing. It has just by a question of how badly I designed it, I guess. I suppose it's on me. It is doing the reading of files line by line. Can you imagine that, man? No, that's no good. That's no good. So yeah, this is not what we want to do because it's with a large file, right? So this would be faster if you had like a one-off script that was like less than 100 lines. In that case, you could make an argument that this is fast enough. But for large files and multiple files at that, this is too slow. This is too slow because it's more overhead. It's way more system calls than just one, read the whole thing into a big old buffer. So basically, we would have to replace this section of code with just reading the entire file, because that's the only way we can get a proper speed up in here. And yeah, that does mean we do have to rethink some aspects of the parser. But worry not, I can do this. I've done code refactors all my life, so I know exactly what I have to do. And this time around, we have tools in order to facilitate all of this. We have the theme find in order to detect certain patterns within the code. We have a good way to profile thanks to the NYT prof, right? So we have lots of tools we can use in order to make this even better than before, and that's what we're gonna do. So yeah, this is now actually that was all from me, and have a good one. I'll be out at work. Bye.